Hello, everyone. So, today we'll be talking about an interesting topic on how we can deploy applications using harness, CI/CD pipeline, as well as how we can inject the chaos test, or you can say, default injection in the applications using harness only. And post that, we'll be doing monitoring of that application using Grafana, and we'll be doing the Grafana cloud, and we'll be doing the load on that application using Grafana K6, the open source Grafana K6, and it will be completely automated. A demo that we are going to do it today. So let's see how we need to do it. So first of all, you need to create a harness account, and post that you need to come back to this continuous delivery GitOps section. Suppose that there's a pipeline that you need to get it to create. So before creating a pipeline, the connections and all those configurations needs to be done. Let me share you things what needs to be done. You need to come to the project settings and then install the relevant delegate so that it can be the harness can get connected to your cluster, right? So in our case today we have a mini cube cluster, so we have installed the relevant delegates is basically the relevant helm charts, and those helm charts are responsible for connecting it to our mini cube cluster. So we'll do it from fresh. We need to create a pipeline. We'll create pipeline from scratch, right? And then let's give some name on this. Suppose test pipeline. Okay, we'll be doing start, and then we'll be adding a stage. We'll be clicking deploy. Now we'll be clicking Kubernetes from where I need to deploy my application. So I'll be clicking this. I need to give some name. Uh, Deploy. Suppose I'm giving a name of deploy, right? Then I need to select a service. Now service is nothing but from where your the manifest will come. So I'm selecting a service called a spec clinic. It will show me from where the data is coming. If I click on edit, so that will show me the data is coming from a GitHub repository. So what I'm saying, my source code is present in my GitHub repository petclinic.yaml, and I'm connecting this deployment.yaml, which contains service also will get deployed using this service. You can see there's a GitHub connector which is actually pulling up that file directly from the repository, and then this will get deployed. So we are not doing kubectl apply on those manifests. We're simply connecting it to this GitHub connector and then picking up this petclean.yaml from this repository, right? Now the environment is nothing but where you need to install. So in our case, the environment is the minikube cluster where we are running it. So this is the cluster I'm talking about, and let me go back. Okay, so service has been selected. I'll click on continue, and then I'll select the let me select the minikube cluster. I'll specify the minikube infra is nothing but your the infrastructure where it will get deployed. I'll click on continue, and I'll click on the rolling deployment, and then this is pretty much. I'll just save, and then I'll click on run. So this will actually run your pipeline, and this will deploy the application to your minikube cluster. Let's go back to our cluster. This is the minikube cluster I'm talking about. Okay, and we are onto the metrics namespace. Correct? And do we have any? Uh, yeah, you can see the pet clinic application is getting created. So this is getting created from harness pipeline. You see this is getting created, and this rollout is happening, right? So we can see the console logs also. Now the application is deployed. Now next thing is we need to inject chaos on this application. The application is deployed with two replicas. Okay, let me just quickly go back. Let me create another window. I'm going a bit slow so that we can understand what we're doing. So we can see the application is deployed with two pods. Let's go back to the service of this application. Okay, port forward, and then this is the pet clinic service. So this is the application that has been deployed onto the Minikube cluster using harness. This is a completely automated. This is the pet clinic Spring Boot application, Java Spring Boot application. Now my first step is done. Now since my first step is done, application is deployed. Now I will inject the chaos on this pipeline. Basically, I will inject the chaos. But before injecting chaos, I will do one thing. I will start some putting some load on this application. So I have a K6 script already created in my uh, so let me go back, and then this is that. Fine. Now I've injected certain 500 users on this application, and the results are going into the Grafana, the local Grafana, just for understanding purpose. You can see last 5 minutes the traffic is now coming. So now traffic is also injected. My application is running with the help of harness. It is being deployed. Let's go ahead and inject certain chaos. Okay. I'll come back to my pipeline. Okay. Console view. Right. This is my pipeline. I click this pipeline. Correct. And then I'll add a stage, and then I'll add a custom stage. I'll give some name called as pod delete. I'll set up a stage. Correct. And then I'll add the step. I'll scroll down to the bottom. I'll click on chaos section. Now in this chaos, I have already created a pet clinic pod delete experiment that will delete the pod. I'll show you the pod delete thing in this. I'll just apply changes. Okay, this will get added to my pod delete, and then I'll save. Now before I trigger this thing again, let me show you the where is that pod delete chaos experiment I have created it. So currently I'm showing you the GitOps CI/CD. I'll show you the chaos engineering module in the same harness module. So I'll come back here. You see, this is the chaos engineering. Bear with the slowness because so many things are running. So I'll come back to my chaos experiment. So you can see there's a kind delete pet clinic experiment that is there, and in which I am doing a pod delete, right? What is the pod delete? You can see the what I'm saying. Please go back to my metrics namespace and the kind deployment, and there's a label called as app equals to pet clinic. Go ahead and delete one of the container or one of the pod from this, and there's a probe also that will continuously check the health of this application and give the resilience score, right? Now, this is the full connectivity that we are doing, and we'll monitor this application also after this. So let me go ahead and run this again, right? Now, this will do the complete run again for, first of all, it will do the deployment, and then it will do the chaos, testing. So let me go back and let me show you the live status of all the pods, right? Minus W. Now you see the applications are yeah, the applications will get deployed. If it is not deployed, okay, it will get redeployed on the pet clinic. The pet clinic will redeploy on the cluster, and then the chaos will get triggered, right? So rollout is happening. So what we are doing, I mean, a quick summary, we are actually connecting our any cluster, Minikube cluster, or any in Azure or Amazon cluster with the harness, and then sending the request from those things using API calls. So you see, the kind pet clinic is getting uh, injected. It is creating the pods, and then it will once the pod is created, then it will inject this pod delete experiment. Okay, now you can see the pod is created. Let me see the KGP kubectl get pods will tell you. uh, Let me do that thing here anyway. Yeah, you see the pod has been created. Now you can see the pod injection, the pod delete has been triggered, right? And this load testing is already going on, so the system is behaving a bit slow. So load is also now happening on this. So chaos is running. Let me go back and remove that console view. Now you see the now the chaos is running. You can see the detailed execution of this chaos. While clicking this, it will take you to the exact chaos that is happening. Okay, so this is that is running, and I can see the same thing here also. KGP minus W. Yeah, so this is going to get initiated. The pod delete. Now you see the pod has been. It is still injecting. Second. Now you can see the pod delete experiment has been triggered. It will delete one of the pod and then it will test the resiliency because we have two containers. So one container will remain active always. So it will give you a resilience score of 100% for sure. And we can bring down that resilience score to 50% also if we keep one instance of that application. That is what how we can monitor the application. So this is all about doing the chaos testing. So you can see the pod delete is happening. The pet clinic now application is getting recreated. Now you can see certain errors are coming. In the meantime, this load is getting, see now my load is getting failed, and it will be giving. So for intermittently, this load has been stopped because I can see this a lot of request has been failed, and similarly. Uh, uh, I mean, the requests are failing for a few instant of time, few seconds of time. After that, the pod will, come up, and then you can see the similar. You can see the vet clinic is coming up nicely. Generally takes some time, but it will give you a better result. And you can see the similar thing. Not here, basically. Let me go back to the chaos pipeline. Let me show you the run history. So how you can check it on your harness portal. Yeah. So this is, running as of now. Now you can maximize these logs. Now you can see the probe is trying to check whether the application is, running perfectly or not. So that is the beauty of readiness probe. It will check continuously for status 200, and unless it is not able to find, it will not give you success. And you can see it was not coming success within a fraction of 10 seconds. So it has, failed that execution, and it will give you, I think, 50 percentage of your resiliency. So bot delete is a very, very important experiment. If it is not returning, 2 out of 3 success, you see success ratio should be 2 out of 3, then the bot delete will fail. So that is pretty much onto the chaos uh, pipeline deployment using harness and the chaos injection. Not only this, we can do the monitoring of these applications using Grafana. That is something automatic instrumentation that we are doing. Let's go back onto the board and do that stuff as well to complete this demo. So I will install the node exporter. What it will do, node exporter will capture all the infrastructure related matrices or infrastructure details from the cluster, and then we'll try to get these data to the Grafana cloud, right? We'll be installing a node exporter onto your matrix namespace. I'm hoping I'm into the matrix namespace. Let me see the KGP. Yeah, the node exporter is now running. Okay, before I run Alloy, now Alloy is another agent that will capture the matrices from this cluster, and then we'll send that matrices to Grafana cloud. In this case, we are using Grafana cloud, but we can use anything else also for your monitoring. So I'm just capturing the cluster IP of node exporter, which will be used for monitoring. I'm going back. I will create this config map. That config map will help us to capture the data, and that will send to your Grafana cloud. So we are using all the latest and greatest monitoring technologies. Okay, so Del, I will delete this config map. So we are using Grafana Alloy as an agent to send the data to Grafana uh, cloud. We can send this data to Grafana open source also. and then we will. So the idea of this demo is to showcase the deployment, the chaos, as well as the monitoring using open source tools. Now you can see the Grafana Alloy has been installed. Now I will install Grafana Bela, which is an auto instrumentation which will instrument all your applications or services that are deployed in this cluster. Right now, Grafana Bela is also being installed. Let me see the status of. You see, Bela is getting created. Let me do KGP. Now Alloy is created, Bela is created, your node exporter is created. I hope now you will be able to see all the matrices on your Grafana cloud. So let me go back into the Grafana cloud, which is this one. I hope, yeah, it is running. And I'll come back to the Explorer window and we'll see how many matrices are really coming from last, 5 minutes or so. So yeah, node exporter data is coming, which is okay, which is fine. But now what I'll do, I will just for 5 minutes, I will, yeah, node export data is coming. I will delete the the applications that will uh, you know reinstate your basically the Bela will do the auto instrumentation. That is really important to restart your application. So here we are just trying to restart the application that will start picking the data related to auto instrumentation that we want to show. Okay, so now you see the pods are now running automatically. Pods are coming up, and then we'll see some more matrices now. Yeah, see, the moment I restarted my the Alloy agent, the Grafana Alloy agent, and the other application, now auto instrumentation matrices are coming nicely. You see, these are all auto instrumentation matrices, and even we can go to the tempo traces that will show you the traces pertaining to whatever filtration we want to do. Suppose I have a query that I want to run. Suppose I want to search. This is behaving very slow. Okay, suppose I want to check for node exporter. Suppose, okay, so I can get all the relevant traces for that node exporter. Right now, not only this, we can quickly see the dashboard. Also, there's a popular Grafana Bela dashboard that will give you the rate error duration of any particular service. Suppose I want to check for node exporter service, or for that matter, I can get the rate error duration for node exporter, as well as I can run the pet clinic again. It will give the pet clinic rate error duration also, right? So since it will do auto instrumentation, let me create some traffic on this. Yeah, now I have created a lot of traffic. Now you will see everything related to the uh, pet clinic also, hoping that it should. Yeah, and what else? I can show you the infrastructure monitoring also. So here the infrastructure monitoring is happening. Let me, yeah. So this is the cluster IP that I refreshed. Oh, I think this is the one. Yeah, this is the one. Correct. So you see last 5 minutes, I can get all the data related to. So this is all infrastructure monitoring we are doing, and we have seen the application level monitoring. Also, I can see the application level monitoring here as well into the application section for last 30 minutes. You see, okay. Let me I can. I want to just a second. I want to show you the application level matrices also. Okay, so maybe the free try. Okay, let me show you the other dashboard, the red dashboard again. Yeah, this is the one that will show you the application level matrices, or you can go back and then check one more dashboard, the open telemetry for HTTP services. So this is again the open telemetry based. It will give you a service mesh, how the requests are going, and all the other relevant details, right? So that is, let me show you the pet clinic. Yeah, you can see the service name pet clinic, and now you can see the details related to pet clinic also. Quick recap. Let me just quickly summarize what we have done today. We have actually deploy application using harness as a GitOps principle using CI/CD. Post that in the same pipeline, we injected one chaos experiment. We can inject many chaos experiments. So since it got failed, that's okay. That is the reason it is giving resilience score 0. But and then we injected the chaos experiment. Post that we did the monitoring of this application using Grafana agent, Grafana open source agent, the Alloy as well as the Bela, which is the open source flavor of auto instrumentation. You can see the Grafana Alloy is the agent for capturing the data, node exporter for infrastructure monitoring, this for application monitoring, and this for auto instrumentation. So we did monitoring also. We did chaos injection also on with one experiment. We can do a number of experiments. So yeah, I will like to take a pause. If you have any doubts and queries, we will try to help. Mm, from next sessions. Thank you for now.